China's megaprojects left US engineers speechless. This defies physics. Prepare to have your understanding of engineering rewritten. China isn't just building infrastructure, it's defying the very limits of what's considered achievable. Witness high-speed trains that effortlessly hit 350 kilometers per hour, traversing incredibly diverse terrains on a network spanning over 45,000 kilometers, connecting a nation on an unprecedented scale. Then there's the Shanghai Maglev, a train that floats above its tracks, reaching a staggering 431 kilometers per hour, offering a glimpse into a truly airborne future. These aren't just projects, they're audacious statements of human ingenuity, pushing the boundaries of physics and challenging global perceptions of progress. What are the secrets behind these massive undertakings? And why do even the most experienced engineers find them incomprehensible? Then, don't forget to like, subscribe, and hit the bell icon so you never miss an adventure into the unknown. Let's explore the secrets of our world together. In the 21st century, few nations have redefined the art of movement the way China has. With a vision that blends engineering mastery, national integration, and environmental foresight, China has constructed the largest and most advanced high-speed rail network in the world, stretching over 45,000 kilometers by 2025. No longer a distant dream or a flashy experiment, high-speed rail in China is an everyday reality, one that connects people, economies, and cultures at speeds that once seemed impossible. On the other hand, the US high-speed rail system only spans over 456 miles, with its fastest Amtrak train reaching speeds of 150 miles per hour.
In the case of the US, as we can see, a lot of the north-south corridors are based on hundreds of years of the old tracks. There are also tunnels and curvatures and bridges that are really old that cannot really allow the trains to run at a faster speed.
Trains in China's high-speed railway system can reach speeds up to 350 kilometers per hour, 217 miles per hour. But the real achievement lies not just in speed, but in reach and resilience. These bullet trains traverse vast distances across a country with an incredibly diverse topography, soaring over rivers, boring through mountains, and reaching into remote rural areas that once felt disconnected from modern development. In effect, China has used rail to stitch together a continental-sized nation, bringing distant provinces closer to its coastal megacities. Families are reunited faster, goods travel quicker. Students attend universities in faraway cities without losing touch with their hometowns. Tourism flourishes, commerce accelerates. The implications are immense.
Chinese didn't invent high-speed rail, but boy, have they adopted the idea and run with it.
China's high-speed railway doesn't serve just the rich or urban elite. It's a people's network, carefully planned to include second- and third-tier cities, lifting entire regions through greater mobility. What makes it special is that the high-speed railway was not simply laid where it was easiest, but where it was most needed. To build it, engineers confronted some of the most extreme geographic challenges on Earth. Entire mountain ranges were tunneled through. Long, elevated viaducts were constructed to cross earthquake-prone zones and floodplains. Advanced earthquake sensors and smart signaling systems were deployed to ensure safety at speed. The result? A network that is not only vast, but also among the safest and most punctual in the world.
They are really required to have a more smoother curves. They needed to have a more slower gradients, and so that allowed the trains to run smoothly and safely.
Among all the lines, the Beijing-Shanghai high-speed railway stands as the ultimate emblem of success. Spanning 1,318 kilometers, this route links the political capital in the north with the economic capital in the south in under 5 hours. That's a journey comparable to traveling from Paris to Barcelona in half the time of a flight, when considering airport procedures. Opened in 2011 and designed for speeds of 350 kilometers per hour, this route was once controversial for its cost and ambition. But today, it's one of the most profitable high-speed lines in the world, carrying over 100 million passengers annually. Its stations connect industrial cities like Tianjin and Nanjing, and cultural hubs like Suzhou, turning what was once a multi-day journey into a routine business trip. The high-speed railway system has profoundly reshaped how Chinese people live and work. Commuting between cities has become not just feasible, but routine. Entire high-speed railway cities have emerged as urban developments and real estate zones built around train stations. Businesses set up offices near high-speed terminals to gain logistical advantages. Talented workers can accept jobs further afield, knowing they're never too far from home. Environmentally, high-speed railways have significantly reduced short-haul flight traffic, which is far more carbon-intensive. Trains are powered primarily by electricity, and many lines are supplied by renewable energy sources. As China aims for carbon neutrality by 2060, high-speed railway is a key player in the country's green transportation strategy. While early high-speed trains relied on foreign technology, notably from Japan, Germany, and France, China has since developed its own models, such as the Fuxing series, which are entirely domestically designed and manufactured. These trains include real-time diagnostic systems, AI-enhanced safety protocols, and ergonomically designed cabins that make long-distance travel not just fast but incredibly comfortable. Even ticketing and boarding have been digitized. A traveler can now purchase a ticket via a mobile app, check schedules in real time, and board using facial recognition at automated gates, all without printing a single document. China's high-speed railway isn't just a network, it's a statement of possibility. It demonstrates how strategic investment in public infrastructure can elevate the national standard of living, reduce inequality, and support long-term economic resilience. This railway system has given the Chinese people something more powerful than mobility: a sense of connection to their country, their communities, and their futures. And yet, as groundbreaking as high-speed railway is, it is not the final frontier of Chinese transportation technology. While most of the world is still catching up to the speed and scale of China's high-speed railway, Shanghai has taken a bold leap into the next era of transport with the Shanghai Maglev train, the fastest commercial train in the world. Powered by magnetic levitation, this marvel defies conventional rail norms by floating above its tracks, traveling at an astonishing 431 kilometers per hour, 268 miles per hour. What makes the Maglev special? Why is it not yet the new standard? What is its role in China's broader transportation future? Let's dive into that high-tech story next. In a world still grappling with traffic congestion and noisy subways, Shanghai dares to offer something otherworldly: a train that doesn't touch the ground. The Shanghai Maglev train, short for magnetic levitation, is the fastest commercial train in the world and perhaps the most futuristic transport experience currently available to the public. At speeds up to 431 kilometers per hour, 267 miles per hour, this sleek bullet glides silently above its tracks, covering 30 kilometers in just over 7 minutes. While it may seem like science fiction, the Shanghai Maglev is not a prototype or a test system. It's real, it's operational, and it's open to anyone landing at Pudong International Airport who wants to witness what the future feels like. What makes the Shanghai Maglev truly revolutionary is not just its extraordinary speed, reaching up to 431 kilometers per hour, 267 miles per hour, but its reliance on magnetic levitation rather than conventional mechanical systems. Unlike traditional trains that grind along tracks, the Maglev floats silently and seamlessly a few millimeters above its guideway, suspended by electromagnetic forces. This contactless motion means there's no wheel-rail friction, no mechanical wear, and virtually no maintenance required on moving parts. Developed with Germany's Transrapid technology, the system uses electromagnetic suspension, where electromagnets on the train interact with ferromagnetic rails to lift and stabilize the train. Separate magnets provide propulsion and braking, allowing precise high-speed control. The result is a gliding experience that feels more like flight than rail travel: quiet, efficient, and futuristic. The Shanghai Maglev isn't just a train, it's a symbol of how engineering and physics can unite to redefine modern transportation. Riding the Shanghai Maglev is a sensory experience that borders on the surreal. The initial thrust is smooth yet thrilling, pushing passengers gently back into their seats as the train glides effortlessly toward its peak velocity. Within moments, the outside world becomes a whirl of color and motion. Skyscrapers melt into brushstrokes, and roads dissolve into streaks. There's an almost dreamlike quality to the ride, as if one has left the physical world behind and entered a stream of pure velocity. Inside the cabin, the atmosphere is calm and spacious. The lack of engine noise or track clatter is striking. Conversations remain soft, and even at over 400 kilometers per hour, one can balance a coin upright on the window ledge. It's a unique blend of speed and serenity, unmatched by any other form of public transport. For travelers, it's more than just a commute. It's a 7-minute glimpse into the future of motion. When the Shanghai Maglev launched in 2004, it was a visionary leap into uncharted territory. As the world's first commercial maglev system, it symbolized China's willingness to take calculated risks on advanced technologies. Critics at the time questioned the logic of spending over $1.2 billion on a 30-kilometer route that served mainly airport passengers. But the investment was never just about transit, it was about positioning China as a global leader in futuristic infrastructure. The Maglev became a technological showcase, demonstrating the viability of magnetic levitation at commercial speeds and offering a glimpse of what transport could look like in decades to come. More importantly, it functioned as a testbed for homegrown development. Engineers collected years of performance data, refined operational systems, and trained a new generation of transport specialists. Today, the experience gained from Shanghai's line is powering China's ambitions to deploy next-generation maglevs, including a 600 km/h prototype, which could eventually connect major cities in mere hours. While the Shanghai Maglev is a marvel of engineering, it remains somewhat isolated, a technological jewel not yet fully embedded in the city's broader transportation web. Its current 30-kilometer route, linking Longyang Road Station to Pudong International Airport, is not connected to China's vast high-speed rail system or deeply integrated into Shanghai's metro network. This disconnect reduces its practicality for daily commuters, who often opt for more affordable, connected options. Efforts to extend the Maglev to Shanghai Hongqiao Airport or even Hangzhou have long been proposed, but repeatedly stalled due to high construction costs, land acquisition challenges, and public concerns over noise and safety. China's high-speed rail system is one of the most modern and extensive networks in the world, but it still faces several limitations. Firstly, the construction and operating costs are extremely high, causing many routes to run at a loss and putting pressure on public debt. Secondly, economic efficiency is uneven, as lines passing through sparsely populated areas are underutilized. In addition, ticket prices remain expensive compared to the income of rural residents. The system also negatively affects traditional transportation and has adverse impacts on the environment. Moreover, maintaining high speeds consumes a large amount of energy, especially on routes with low passenger volume, which reduces operational efficiency. These challenges need to be carefully considered.
Although they would be very fast and very efficient, is because it takes quite a bit of energy in terms of cooling power to get the superconducting material in their superconducting state.
Yet, despite these limitations, the Shanghai Maglev remains a powerful symbol of what's to come. A future of clean, ultra-fast, and frictionless urban travel, a bold leap toward the cities of tomorrow. The Maglev is more than a transport solution. It's a symbol of China's ambition to lead in futuristic infrastructure. Every time it floats past, it whispers a quiet message to the world. We are not just catching up, we are creating the future. But while the Maglev steals the spotlight with speed, another record-breaking marvel supports China's high-speed ambitions quietly and on a massive scale. Stretching across the eastern plains of China is a feat of engineering so long, it must be seen to be believed. While the Shanghai Maglev floats on air, the Danyang-Kunshan Grand Bridge spans the Earth. At an astonishing 164.8 kilometers, it is the longest bridge in the world, built not just as a wonder of construction, but as a backbone for the Beijing-Shanghai high-speed rail, the very artery of China's high-speed rail miracle. Let's now explore how this epic structure redefines what's possible in engineering, mobility, and scale. In a world of ever-growing cities and ever-faster transportation, infrastructure has become a silent force that shapes destiny. Nowhere is this more evident than in China, where the Danyang-Kunshan Grand Bridge stretches across the landscape like a colossal ribbon of possibility. At 164.8 kilometers, over 102 miles, in length, this is the longest bridge in the world, an achievement so massive it almost defies comprehension. This is not just a bridge, it's a continent-sized engineering miracle, purpose-built to serve one of the greatest transport corridors in human history, the Beijing-Shanghai High-Speed Railway. Stretching an astonishing 164.8 kilometers, the Danyang-Kunshan Grand Bridge is not only the longest bridge in the world, but also a monument to modern engineering and human ambition. Designed to carry the Beijing-Shanghai High-Speed Railway, the bridge was completed in just 4 years, a feat that required over 10,000 skilled workers and engineers working continuously across shifting landscapes and complex environmental zones in Jiangsu province. This colossal structure navigates a tapestry of environments: rice paddies, lakes, wetlands, canals, and urban edges, requiring engineers to elevate the railway above terrain that is geologically unstable and highly prone to flooding and land subsidence. Building on such terrain using traditional rail beds would have risked frequent disruptions. Instead, the elevated design ensures year-round reliability, minimal environmental disruption, and consistent high-speed operation. Constructed with thousands of reinforced concrete piers and prefabricated segments, each component was installed with millimeter precision to accommodate trains traveling at over 300 kilometers per hour. Beyond sheer size, the bridge exemplifies how infrastructure must adapt to both nature and technology, seamlessly linking urban regions while enabling one of the fastest rail experiences on Earth. It is, quite literally, a bridge to the future. The sheer scale of the Danyang-Kunshan Grand Bridge is mind-bending. At nearly 165 kilometers, it dwarfs most global infrastructure projects, standing as a symbol of China's colossal vision and capacity. It's more than 4 times longer than the famed Lake Pontchartrain Causeway in the US, roughly 1.5 times the width of the English Channel, and could easily connect New York City to Philadelphia with room to spare. Yet this massive structure is not just about size, it's a harmonious blend of form and function. Its sleek, rhythmic design flows over rivers, farmlands, and urban fringes with graceful precision. It is a feat of industrial art, combining raw power with calculated elegance, reflecting a nation unafraid to reshape geography in the name of connectivity and speed. Though it often goes unnoticed by passengers hurtling along at over 300 kilometers per hour, the Danyang-Kunshan Grand Bridge is an invisible backbone of the Beijing-Shanghai High-Speed Railway. By elevating the track, the bridge allows trains to maintain consistent high speeds with minimal noise and vibration, free from the disruptions posed by rivers, roads, or uneven terrain. More impressively, the bridge is a model of eco-conscious engineering. Its design minimizes environmental intrusion by soaring above sensitive ecosystems, rather than cutting through them. Farmers still tend their crops beneath its massive piers, and wetlands continue to support native birds and aquatic life. This approach protects both human livelihoods and biodiversity, setting a high standard for future megaprojects. In doing so, the bridge proves that infrastructure at scale can still respect the natural world while delivering cutting-edge performance. The Danyang-Kunshan Grand Bridge is a quiet giant in the story of modern China. It may not have the glamour of the Shanghai skyline or the global fame of the Great Wall, but it symbolizes efficiency, foresight, and unity. It's a bold message to the world. China doesn't just build for today, it builds for tomorrow. Bridges are often metaphors for connection. This one is literal. It connects not only cities, but opportunities, economies, and futures. And as China continues to push the boundaries of transportation, it's not stopping at surface-level innovation. It's now going underground and even underwater. As impressive as floating bridges and magnetic trains are, China is now looking to conquer a new frontier, the sea floor. Underwater tunnels, once seen only in sci-fi or Scandinavian engineering journals, are becoming a key part of China's long-term transport strategy. What's the scale of these tunnels? How are they built? And what do they promise for China's connectivity in the future? Let's dive into the story of China's underwater transport revolution next. When we imagine modern transportation, we often look up towards superhighways in the sky or magnetic trains slicing through clouds. But in China, engineers are also looking down, deep beneath the surface of rivers, bays, and oceans. There, away from the eyes of the world, underwater tunnels are quietly weaving together the nation's most vital coastal arteries. These feats of subterranean engineering represent not just technical skill, but bold imagination, transforming seafloors into corridors of trade, travel, and national unification. Over the past 2 decades, China has constructed a complex web of underwater tunnels connecting major coastal cities, islands, and ports. These tunnels do not merely support local traffic, they are part of a national strategy to integrate regions, accelerate economic flows, and reduce dependence on ferry systems. Hong Kong-Zhuhai-Macau Tunnel, part of the 55-kilometer sea crossing. This massive submerged tunnel links 3 key cities in the Greater Bay Area under the Pearl River Delta. Qingdao-Jiaozhou Bay Tunnel, one of the longest undersea road tunnels in Asia, linking the eastern and western districts of Qingdao. Xiamen-Kinmen Tunnel proposed, a planned underwater tunnel to potentially connect mainland China to Taiwan, controlled Kinmen Island, a move charged with both technical and political complexity. Dalian Yantai Tunnel, planned, a future 123 kilometers subsea tunnel under the Bohai Strait, potentially the longest underwater tunnel in the world. Each of these structures represents a radical rethinking of geography, treating water not as a barrier but as a passageway. Building underwater tunnels is one of the most complex feats in modern engineering, requiring a fusion of precision, resilience, and innovation. Techniques like immersed tube tunneling involve assembling precast tunnel sections on land, floating them into position, then sinking and sealing them within dredged seabed trenches. Tunnel boring machines carve deep beneath the seabed, ensuring minimal surface disruption, while shield tunneling offers extra support in unstable or waterlogged soils. These methods demand advanced waterproofing membranes, real-time monitoring, ventilation systems, and pressure regulation to ensure the tunnel's safety and longevity. Engineers must also design for earthquakes, saltwater corrosion, and intense traffic loads. Despite these challenges, underwater tunnels offer unmatched connectivity, linking islands, ports, and urban zones with minimal environmental footprint and maximum engineering finesse. China's underwater tunnels are not only remarkable engineering achievements, but also key strategic assets tied to the country's long-term development plans. By linking islands with coastal cities, these infrastructure projects promote regional connectivity, reduce travel time, and facilitate smoother industrial and trade flows. This translates to more efficient supply chains for businesses and faster, more reliable transportation for commuters. Back in 2023, in Wuhu City, eastern China, construction was underway on an underwater tunnel beneath the Yangtze River. At that time, Xinhua reporter Xi Shiwei visited the site, located 45 meters underground, to learn about the construction process and the complex engineering challenges it faced.
So this tunnel is designed as a fast lane urban highway with a design speed at about 80 kilometers per hour. So they began the construction of this tunnel at the end of 2019, and they will finish the construction and open this tunnel to traffic by the end of 2024.
Beyond economics, these tunnels carry geopolitical significance. In sensitive areas like the Taiwan Strait or South China Sea, such infrastructure quietly reinforces territorial presence and logistical readiness, offering dual-use potential for both civilian and military applications. Additionally, their resilience against typhoons and maritime disruptions gives China a strategic edge in climate-vulnerable zones. In essence, underwater tunnels encapsulate China's drive for convenience, security, and strategic reach beneath the surface. Unlike the grand aesthetic of high-speed trains or suspension bridges, underwater tunnels are invisible marvels. You may never see the innovation, you simply feel it in shorter travel times, smoother cargo delivery, and a strange awareness that you're flying underwater in a car or train. These tunnels are part of a new chapter in China's infrastructure story, one that proves engineering does not always shout. Sometimes, it hums softly beneath the ocean. But while underwater tunnels conquer the deep, another infrastructural giant rises from the waves above, serving as the beating heart of global trade. Rising like a fortress from the East China Sea, the Yangshan Deep-Water Port is not just a port, it's an entire floating world of shipping lanes, container yards, and robotic cranes. As part of the Shanghai port system, it helps China move over 40 million 20-foot equivalent units of cargo annually, securing its place as the busiest container port on Earth. Let's now explore how this island-born port has reshaped the balance of global logistics. In the middle of the East China Sea, nestled among a string of rocky islets connected to the mainland by an immense sea bridge, lies a place where robots load ships, cranes dance with code, and supersized vessels come to breathe. This is Yangshan Deep-Water Port, the largest fully automated port in the world, and a symbol of China's relentless ambition to dominate the future of maritime trade. More than just a shipping hub, Yangshan is a city of steel and sea, where artificial intelligence, fifth-generation, autonomous vehicles, and machine vision come together to move cargo with machine-like perfection. It is a place where humans step aside and let the future run the dock. The creation of Yangshan Deep-Water Port is a story of audacity, ingenuity, and strategic foresight. Faced with the challenge of accommodating ultra-large container vessels, some as long as 4 football fields, Shanghai's traditional river port simply lacked the deep water draft required. Instead of expanding inland, China made the bold choice to engineer the ocean, transforming the remote and rocky Yangshan Islands into one of the world's most advanced maritime gateways. To connect this artificial deep water marvel with the city's logistics network, engineers constructed the Danyang Bridge, a 32.5-kilometer-long sea bridge, one of the longest in the world, cutting across high winds, powerful currents, and unpredictable weather. Opened in 2005, the port was designed not only to handle the world's largest cargo ships, but also to do so with unprecedented efficiency. Equipped with automated cranes, AI-driven logistics systems, and vast container yards, Yangshan is now a centerpiece of the Shanghai Free Trade Zone. It processes millions of 20-foot equivalent units annually, helping Shanghai Port maintain its position as the world leader in container throughput. More than just a port, Yangshan is a statement, a symbol of China's unrelenting push toward global trade dominance through engineering excellence. What truly distinguishes Yangshan Deep-Water Port is its remarkable level of automation, making it a global pioneer in smart port technology. The port's operations rely heavily on unmanned guided vehicles that autonomously transport containers across vast container yards with pinpoint accuracy. Towering automated stacking cranes and remote-controlled gantry cranes efficiently lift and sort thousands of containers daily, all coordinated seamlessly through AI-driven control systems. Since the launch of Phase 4 in 2017, Yangshan has become the largest fully automated container terminal worldwide, capable of handling over 6 million 20-foot equivalent units annually, all without human operators physically driving vehicles or climbing cranes. Even the skies above are patrolled by maintenance drones, scanning for structural issues and potential equipment faults before they escalate. In this high-tech environment, data acts as the dock worker, orchestrating every movement and decision with millisecond precision. Yangshan exemplifies how automation transforms not just productivity but the very nature of labor and logistics in the 21st century. Yangshan Deep-Water Port is far more than a technological marvel. It's a vital artery in the global economic bloodstream. Every day, hundreds of container ships from Asia, Europe, North America, and Africa dock here, making Yangshan a pivotal hub in several major initiatives. The Belt and Road Initiative, the Maritime Silk Road, and China's strategic dual circulation economic model that balances exports with growing domestic demand. Thanks to its cutting-edge automation and 24/7 operations, the port achieves remarkably fast ship turnaround times, cutting them by over 50%. Coupled with real-time customs clearance and ultra-efficient cargo handling, Yangshan gives China a critical competitive advantage in global trade. It not only boosts Shanghai's status as a world-leading port, but also reinforces China's role as a central node in international supply chains and economic connectivity. Yangshan Deep-Water Port is pioneering a new era where massive scale meets environmental responsibility. The port's fleet of electric automated guided vehicles significantly reduces reliance on diesel-powered machinery, cutting greenhouse gas emissions and noise pollution. Its shore-to-ship power systems allow docked vessels to shut off their engines, slashing air pollution in the harbor. Beyond hardware, advanced AI-driven energy management programs optimize lighting, machinery use, and cooling systems to maximize efficiency and minimize waste. By integrating sustainability at every operational level, Yangshan sets a powerful example for the world, proving that ports can be intelligent, highly productive, and environmentally responsible all at once. Standing at the edge of the pier at Yangshan, watching the cranes operate without hands and the containers move in silence, one can't help but feel a sense of awe. This is not just a port, it is an orchestra of algorithms and ambition, a place where China turns the sea into a gateway of prosperity and possibility. Yangshan Deep-Water Port completes a grand vision linking underwater tunnels, mega bridges, high-speed trains, and levitating maglevs into a living, breathing ecosystem of motion. It is a monument not built in stone or bronze, but in steel, sensors, and data. In China, infrastructure is not merely background, it's the star of the show, telling a story of how geography, technology, and vision can rewrite the rules of connection. From tunnels beneath the sea to ports above the waves, this is a nation not waiting for the future. It is building it, container by container, kilometer by kilometer. China's megaprojects, from its colossal high-speed rail network and the levitating maglev train, to the world's longest sea bridge, deep-sea tunnels, and ultra-automated ports, aren't just feats of engineering. They embody a bold vision where technology and ambition merge to redefine what infrastructure can be. These aren't merely record-breaking constructions. They are powerful drivers of economic growth, regional connectivity, and improved quality of life. China has proven that with strategic investment, what once seemed impossible can become a stunning reality, opening up endless possibilities for the future. If you found these stories of mega projects fascinating and inspiring, don't forget to subscribe to our channel, like, and share this video to help us continue bringing you even more captivating content.